All right, hey guys, welcome back to another video. So today I'm going to be talking about trig subs. And so the way that trig subs work is we're basically going to take a variable that, well, it works pretty much the same way as like a regular substitution, like a u sub. But the only difference is we're substituting in a trig function. But that's pretty much it. That's like the real difference. So the reason that we want to do that is because trig functions have plenty of identities that we can work with, and we can manipulate the problem using these trig identities, and that makes it super easy for us, right? So at the heart of trig substitution is we're trying to mess around with the integrand, right? And so I want you guys to get in the habit of not thinking about, okay, if I have an integrand that has like an x squared minus a squared, I'm going to use like a cosine, a secant, or a tan. I want you guys to get in the habit of, okay, if I'm presented x squared minus a squared, what kinds of trig identities can I try to manipulate so I can get something inside the integrand that looks nice? So what that looks like is, let's say that I'm considering this integral right here. My integrand is the square root of x squared minus a squared. So things that we want to look at is, okay, I have an x squared minus a squared. Which identity has like a minus constant? Well, of the two identities that I've written in the red, none of them have a minus constant. But that's not a problem, because the thing about trig identities is that we can manipulate them. So what that looks like is, for this second identity, I can rewrite this as tangent squared is equal to secant squared of x minus 1. So now I have that minus constant that shows up in this integrand as well. Just not exactly what we want just yet. So now this is where I'm going to have to start thinking about my substitution. I need to introduce a secant squared, and I also need to introduce a constant so that I can change that a squared to a 1. So what this looks like is, okay, I need to introduce a secant squared. I already have x squared in there, so that means I just need to introduce a secant. We'll do secant of theta. And then what we also have to do is we need to introduce another a squared. So what I can do later is I can factor out that a squared so I can get a 1, right? So since I already have x squared, I'm just going to let x be equal to a secant theta. And so when I do the substitution, I'm going to end up with the square root of, I let x be equal to a secant theta. So now I'm going to have a secant theta, all of that squared, minus a squared. Some simplifications yield a squared secant squared theta minus a squared. More simplifications. Now what we notice is I can factor out an a squared. So now I have secant squared of theta minus 1, right? So this piece matches this identity right here. So now I have the secant squared minus 1. I know that I can rewrite this as tangent squared. So now I have a squared tangent squared theta. See, and now everything starts to cancel out very, very nicely, because now I have the square root of some squares. So now I'm left with a tan theta, right? And so this is the kind of this is kind of the thought process behind like the key idea or the theorem in the book. This is kind of the thought process I want you guys to start practicing, because sometimes these things aren't as nice, and you should know, instead of looking for like something to clue you in on what it has to be, you should start looking for, how can I manipulate things so that it is what I want it to be. So I hope this was helpful to you guys. I hope you learned something. Thanks for watching.